Dr. Chanchaldeep Kaur with another interesting and learning episode of B.Pharmacy on the important unit of Central Sterile Supply Unit and their management, which is very important unit of the section of Clinical and Hospital Pharmacy of B.Pharm 7th semester. Let's start our episode while taking a look at what we are going to learn today. Module 3, Packing of materials prior to sterilization. Module 4, Sterilization equipments. Module 5, Supply of sterile materials. And Module 6 is Conclusion. Module 3 is Packing of materials prior to sterilization. The items to be sterilized must first be packed using suitable material. The sterile package has a very important job to fulfill, demanding materials with special properties. The packaging must protect the contents so that they can withstand normal handling without being damaged and also allow sterilization to take place. It must then keep the contents sterile until such time as they are used. For factory sterilized goods, the packaging must also carry information such as size, model, manufacturer, date of manufacture and expiry date. Instruments and other items that are prepared for sterilization must be packaged so that their sterility can be maintained to the point of use. The materials and techniques used for packaging must allow the sterilant to contact the device during the sterilization process as well as to protect the device from contamination during storage and handling before it is used. The time between sterilization and use may range from a few minutes to several weeks to many months also. The packaging material selected must also permit the device to be removed aseptically. The various types of packaging materials include: first, textiles; second, non-wovens; third, pouch packaging; fourth, rigid container systems. The packaging materials used in hospitals are as follows. First, plastics. Plastic materials play an important part in the manufacture of transparent pouches used in hospitals. The transparent side consists of two different thin films laminated together, making the contents visible and allowing the pouch to be sealed by heat and pressure. The outer layer of film is polyester, which is very strong and has a high melting point, that is around 250 degrees centigrade. The inner layer facing the paper is polypropylene with great elasticity and a low melting point, that is 160 degrees centigrade. This means that only the inner film melts when it is heat sealed, forming an internal bond with the paper. The laminated film is stable enough to survive the sterilization process and gives good protection against recontamination. Although laminated films are always used for hospital pouches, dentists using dry heat sterilization can use pouches made only of nylon film. Next is paper. Paper is the material most commonly used for packaging in hospitals. It is used in pouches and bags, disposable packaging sheets, and in cartons. The paper used in pouches must let steam and gas pass through during the sterilization process when the paper is damp and the pressure in the autoclave is high. In dry conditions, however, the pores must be closed to keep air and microorganisms out. This very special porosity is a unique requisite for sterile packaging paper. It must also have high wet strength so that when the paper is wet, it can withstand the powerful changes of pressure in the autoclave without breaking. The material used for wrapping paper sheets is also very special. It must have the same characteristics as pouch paper, but must also be easy to fold and soft. Its performance with adhesive tape is also important, both in closing and opening the package. Sterile goods must be double wrapped for good protection and to allow opening by accepted sterile procedure. Usually different colors are used, for example, white inside and green outside. And the most common grade is crepe, which is the more elastic. New non-woven is safer and more conforming, and these can be made stronger by adding artificial fibers during manufacture. Next is textiles. Textile packaging sheets are sometimes used, but this is a material which is fast losing popularity because it is not able to meet the modern demands of bacteria barrier characteristics. Textile sheets are used many times and must therefore be carefully examined for damage when any holes must be mended by hand. This and the high cost of laundry make the use of textile sheets very expensive. The selection of packaging material. This is also one of the important characteristics. Industry is able to select the best type of packaging to suit whichever method of sterilization is to be used. For example, when irradiation is to be used, the packaging can be made completely of plastic. Similarly, when the contents are required to remain sterile for a longer period of time, the thickness of the packaging material can be increased accordingly. Using a special coating technique, the inner side of the paper used in packaging can be covered with a special lacquer, making the paper stronger and giving a seal which is very easy to open. Similarly, for factory sterilized goods must travel over long distances and withstand rough treatment. They are therefore often packed in 3 layers. Firstly, every single item is packed and then they are put in a dispenser box, often made of thin cardboard. Finally, a number of dispenser boxes are put in a transportation box. For added security, the dispenser box is sometimes covered with a plastic film. An unopened dispenser box will remain sterile for a very long time. The manufacturer will have printed the shelf life on the outside, and it is today quite common to have an expiry date 5 years after sterilization. For products processed in hospital, CSSDs, the sterile time is of course different, and it may also differ from hospital to hospital due to local rules. Here are the most common ones. Heat sealed paper or plastic pouches for 6 months. Paper and textile sheets for 1 month. Paper pouches 1 month. Sterile goods must be stored properly, and even the packaging material is good, it must be handled with care. Hospitals generally have special main storage facilities for sterile goods, but in the wards they may have to be kept in cabinets and on open shelves. It is important in this case not to put too many packs on top of each other and not to tie packages together with rubber bands. It is preferable if they can be stored in cool and dry conditions. Module 4. Sterilization equipments. Sterile condition means completely free from microorganisms and their spores along with particulate foreign matter. Sterilization is the process to attain this sterile condition. A material is said to be sterile if it achieves 99.99% kill of bacterial spores. The sterilization equipments are the equipments used for attaining this sterile condition. There are various types of methods used for sterilization, and according to the utility of those methods, the equipments are designed. The method to be adopted will be decided according to the nature of material to be sterilized. The sterilizer has to be designed, manufactured and validated as per ISO 11135/2007. The sterilization equipment should be fitted with required number of humidity sensors, temperature sensors, pressure sensors. The material to be sterilized has to be properly packed and sealed in medical grade paper or breathable film pouch and preconditioned before actual sterilization cycle starts. Complete sterilization cycle has to be monitored and should be run on validated parameters. There are many sterilization methods which can be used depending upon its suitability to the products being sterilized. These methods are: first is the physical method, in which there is thermal or heat method, radiation method, filtration method. Second is the chemical method, which has gaseous method. Some of the methods widely used are discussed below. First, moist heat sterilization method. This is used for medical products that are made of metal, are porous, hollow or otherwise thermostable. The sterilizing medium is saturated water vapor which transmits thermal energy by condensing on medical products. Steam sterilization is relatively older technique and can be carried out easily using standardized equipment and without using any hazardous material. Yet sterility assurance level can be achieved. The equipments used are autoclaves like downward displacement, vacuum assisted, pulsed and steam dilution. The conditions are 121 to 134 degrees centigrade at high pressure. Benefits are: the most dependable systems available for the decontamination of laboratory waste and the sterilization of laboratory glassware, media and reagents. The applications of this method are: for porous loads, dressings. Sterilizers are generally operated at a minimum temperature of 134 degrees centigrade, and for bottled fluid, sterilizers employing a minimum temperature of 121 degrees centigrade are used. Second method is dry heat sterilization method. The equipments used are incineration, red heat, flaming, hot air oven. Conditions are 160 to 180 degrees centigrade for 2 hours. The benefits of this method are good penetrability and non-corrosive nature. The applications are sterilizing glasswares and metal surgical instruments. It is also used for sterilizing non-aqueous thermostable liquids and thermostable powders. Ethylene oxide ETO sterilization. This is the next type of sterilization. Ethylene oxide sterilization is used for thermolabile reusable medical supplies made of plastic. The sterilization medium is a mixture of ethylene oxide and vapor that penetrates well. This moist sterilizing process requires a period of post-sterilization aeration to remove toxic residues. Because ethylene oxide is toxic to humans and other animals, the item sterilized with it must be aerated before use to allow the gas to dissipate. ETO indicators, spore strip or bacteriological indicators of required K value should be used as a process challenging device placed in required numbers of critical locations in the sterilizer chamber. These sterilizers are to be placed in isolated areas. After the product is sterilized, it has to be placed in well ventilated area for 72 hours for quarantine aeration, bring down the ETO gas residual level within acceptable limits. By this time, biological indicators also give the result of sterility of the sterilized load, and the sterilized products can then be used safely. Plasma sterilization. Plasma sterilization is used for thermolamine reusable medical supplies made of plastic. The sterilization medium is a low temperature plasma created in a high frequency electromagnetic field that interacts with vapors of 58% hydrogen peroxide in a high vacuum. The plasma sterilization is a dry sterilization process. All sterilization processes are carried out in modern machines with controlled parameters and written records providing details of the sterilization processes. All sterilization processes are rigidly monitored by both chemical and biological indicators. Next comes glass bead sterilizers. Glass bead sterilizers have a central well filled with glass beads which are maintained at high temperature, approximately 500 degrees Fahrenheit. Glass bead sterilizers may be used to sterilize instrument tips between rodents when using a single pack of multiple animals. Instruments must be initially sterilized by steam or glass bead sterilizer gas. The tips of surgical instruments are placed into the hot glass beads for approximately 5 to 10 seconds. Blood and tissue should be wiped off the instrument tips prior to placement in the glass bead sterilizer. Only the tips of the instruments are sterilized using this method. The instrument tips become extremely hot and must be cooled before use. One set of surgical instruments may be used on up to 5 rodents during the same surgical session if the instrument tips are sterilized between each animal using a glass bead sterilizer. Only under special circumstances may glass bead sterilization be used as the sole method of sterilization. The important equipments include autoclave for steam sterilization prior to use in surgery, ethylene oxide gas sterilization, chemical or cold sterilization, and dry heat sterilization, that is glass bead sterilizers. Quality control. First is indicator tapes. Time, temperature, pressure sensitive tapes. It does not indicate for sensitivity for sterilization, but only suggests the required time and pressure the items have been subjected. Second is by bacteriological indicator, kept in center of pack before the process and later on subjected to lab for colony count and growth. A pack of non-pathogenic bacterial spore stereothermophiles is placed in each load to check quality. Clostridium species is generally used as dry heat sterilization indicator. If the level of sterilization is satisfactory, the green or brown color change to black. Personnel should be adequately trained to handle the equipments. Fourth, regular maintenance of equipments be done. Next, the Hospital Infection Control Committee monitors the sterilization by drawing samples and growing in medias for colony count. Reusing instruments. When surgical procedures are to be performed on multiple rodents, The same set of instruments may be used on more than one animal under the following conditions. The instruments must be initially sterilized by autoclaving or gas sterilization. Instruments should be wiped with alcohol or sterile saline to remove blood and tissue particles between animals. The tips of instruments must be placed in a hot bead sterilizer between animals. A new set of sterile instruments should be used after every 4 to 5 animals. If the instruments have become contaminated by contact with a non-sterile surface or non-sterile portions of the body, such as contents of the gastrointestinal tract, a new sterile set of instruments should be used on subsequent animals. Module 5. Supply of sterile materials. Issue and distribution. The function entails issue of the sterilized packages, dressings, linen, instruments and disposables to various departments of the hospitals. The methods of distribution of supplies. The aim is to avoid hoarding of supplies in order to minimize unproductive storage of expensive items, re-sterilization of packs kept for long periods, and also to avoid stockouts during emergency needs. To satisfy above stated conditions, there are 4 systems in use. The one or mix that suits should be selected for particular CSSD. 1-for-1 exchange system. All the used articles are collected in the locked canvas bags and similar number of packs and trays in sterile state and returned to the respective areas. 2 such rounds of collection and distribution are done in a day. The milk round system. Daily topping up of each department's stock level to an agreed level. Maximum daily requirement for all the packs are kept in each department. Delivery and collection rounds are planned twice daily. If single round is made, stock provided needs to be 50% extra, and when 2 rounds are made, the stock provided should be 25% extra of over and above the daily consumption. Third, the grocery system. The departments send to their requisition to CSSD from where deliveries are made in accordance with the demand. This system is sometimes not practical as some departments demand the entire amount of stock from the CSSD, having nothing left for the others. The efficiency of the system depends on the wisdom and experience of the person making the indent. Fourth, the clean for dirty exchange system. According to this system, one clean article is issued for each dirty returned to the CSSD. Despite all measures and advancements in technology, hospital-acquired infections remain a challenge in healthcare scenario today. The hospitals are required to adopt strict quality control processes with the latest cutting technology to mitigate hospital-acquired infections. Module 6, which is the conclusion. With all these information, here we come to end of today's lecture. Hope we have understood the details related to facilities of Central Sterile Supply Unit in the hospitals. Further, have a look again on the complete topic yourself so that you are thorough with it. The topic that we have discussed today is very simple and good. It could be well remembered by correlating with the nearby hospitals that we see regularly in our routine life. So dear students, this is Dr. Chanchal taking leave from you with the hope that you enjoyed and understood today's lecture. We will continue in our next lecture with the topic manufacture of sterile and non-sterile products. If you want to learn more and enhance your knowledge, you may log on to our website for MCQ, quizzes, LORs, www.cec.nic.in. Till then, keep studying. Goodbye.